Hi everyone, I'm Mr. Fullerton, and today I'd like to talk about electric current. Our objectives are going to be to define and calculate electric current. A pretty straightforward objective and a pretty straightforward, nice short lesson. So let's dive right in. What is current? Well, electric current is the flow of electrical charges. And in most electric currents, the charges that are actually moving are electrons, or negative charges. However, because of what Ben Franklin decided as he was doing some research on electricity and what was happening, he called electrons the negative charge. Since they're doing most of the moving, it's a little bit confusing because conventional current flow is in the direction a positive charge would move. Therefore, if an electron is moving or flowing to the right, the direction of our current flow is the opposite direction, to the left. Now, this doesn't mean that you don't ever have currents where positive charges do flow, but in most of the things we're going to look at in this course, we're usually talking about electrons carrying most of the current. So you have to remember conventional current flow, or the direction of current, I, is in the opposite direction that the negative charges, or the electrons, move. Electrons also flow from low potential to high potential. Because they're negative charges, they like going to the more positive, the higher potentials. It's kind of similar to thinking about what happens when you have water going over a waterfall. Positive current flow goes from high potential to low potential. Water, positive mass, for example, flows from high gravitational potential to low potential. Same sort of thing with current. Current goes from high potential to low potential, which means that the electrons, because they go in the opposite direction, are actually going from low potentials to high potentials. So you can almost think of electrons as being floating bubbles going the opposite direction, rising up. Calculating current flow. Electric current, which we already said is capital I, is the amount of charge passing a given point in some set amount of time. So the formula for electrical current, I, is charge Q divided by time, T. And since charge is measured in coulombs and time is in seconds, a coulomb per second is equivalent to our unit for current, which we call an ampere, or amp, and usually abbreviate with a capital A for short. So 1 coulomb per second is equal to 1 ampere. I equals Q over T. Let's put that into practice. A charge of 30 coulombs passes through a 24 ohm resistor in 6 seconds. What is the current through the resistor? Well, current is charge divided by time. Our charge was 30 coulombs. Our time was 6 seconds, so this is a very straightforward 5 amperes, or 5 amps.